my name is Nedim Korjenic, and I'm Vice President of Operations in Authority Partners, for all of you that don't know me. And I'm happy to announce our first online Dev Talks. And I'm very excited on how it's going to be, because this is the, we moved it from the coffee shop where we usually have it, and we have great fun afterwards, to the virtual world, just to keep the continuity and keep everyone happy. So thank you everyone for coming. And I just want to let you know that DevTalks is designed for sharing knowledge and experience. And today we are going to cover 2 advanced industry topics. We are bringing a fantastic trio from Authority Partners and 2 hours of interesting topics. Take the comfortable seat, of course, get some coffee, and let's begin with the first talk by Nedim Korjenic, Authority Partners QA engineer, and then Adnan Mujkanovic, program architect and QA engineer, who are going to talk about release sign-off and how to make it easy to accomplish and ensure quality. After them, we're going to have our Dzemal Cengic, software developer at Authority Partners, and he will talk about Azure Kubernetes service. Enjoy this time and have fun. And I hope I'll see you soon, guys, in the next Dev Talks. Bye.
Thank you, Amina. Hello, everyone. First of all, thank you for joining this session. I will start with sharing my presentation. First, I would like to say that it is my pleasure to have opportunity to present you my knowledge and experience today. I hope you are home and you are safe. Today, Adnan and I will talk about a release sign-off and how we manage to change and improve our process. Tonight, we will talk about release sign-off, regression testing, a sign-off before product release, what is regression test suite, regression test plan, how to build a framework so anyone can automate, how to keep automation solution up to date, to be able to sign off release with automation, and release pipeline to ensure quality. So let's start with the release sign-off. Release sign-off is a process where final build is completed and no other changes are needed. The formal way of declaring this process is a sign-off. QA role is to make sure the team delivery are released that matches the quality standard set before. Next, also important thing is sign-off needs to be final. What this means? If we are able to confirm without external group, this means stakeholders, that we have tested and signed off, then any follow-up request we make will be either bugs or new requests. With new request, we means new work that has to be estimated and scheduled separately. Of course, if we have a good relationship with our partners, we can probably address small changes later without too much drama. But we should know that once we sign off release, there is no guarantees. Also, next important question is who is responsible for signing off release, quality assurance or a product owner? I will say everyone is responsible. Dev team should work on their unit test. QA team should execute approved test cases from the test plan for particular release, and product owner is responsible to approve a release test plan for sign-off. The product owner decides what goes to customers. The QA manager provides the status of the release, but in some cases, the product manager may ship product with bugs, depending on business and market factors. But QA has authority to say whether something is ready for release, but product owner can override QA belief that something is not ready and push out a release. But my opinion is QA and product owner should work together to ensure that what is delivered is of the required and expected quality. And if team is working well, the number of times there is disagreement at the end of the test cycle should be relatively low. So let's start with regression testing. What is regression testing? Regression testing is rerunning functional and non-functional tests to ensure that previously developed and tested software still performs after a change. Each time the software has a change or is updated or is a bug has been fixed, the regression test should be performed. Why? We need to make sure that nothing has been broken with those changes. Also, if there is an environment where updates are constantly occurring, regression testing is vital because with every change there is a new threat to our product. Changes that may require regression testing include bugs fixes, software enhancements, configuration changes, and even substitution of electronic components. So how much a regression test should cover? Complete testing of an application requires exhaustive testing of high number of modules with a large number of test cases execution. So testers or QA should have more focus on their scenarios which are strictly critical nature to the business. Additionally, a scope of any testing depends on the number of features implemented. Also, QA can make a regression test suite, which contains all test cases that will be executed during regression testing. What contains a regression test suite? First, we can have a test template, which contains all regression test cases that are existing for the application. The regression test suite should include regression test cases, promoted test cases for previous releases, and test cases derived from the bugs. This means that we should write test cases for every bug found, so we can be sure that the bug will never reappear. Also, it can include API tests, performance tests, and so on. As you can see from the picture, another good practice to have test suite for every release, as you can see on the screen, which includes all written and automated test cases. So we can have quick overview of those cases, all bugs and all promoted test cases. Promoted test cases means that those test cases will become part of the regression test suite later, or maybe part of the smoke tests. Before regression occurs, we will put everything needed for target release, all test cases for target regression into the regression test suite folder. And this suite will be executed for regression. This means smoke test, API test, performance test, and all needed regression tests should be imported to this suite or folder. On this way, we will always have on one place what is executed and covered in each release. Also, it's worth of mentioning that we have three approaches in theory. First is retest all, second is regression test selection, and third is prioritization of test cases. Test all means that we will execute all regression test cases. This method is very expensive and it requires huge time and resources. Second method is instead of executing entire regression test suite, it is better to select part of test suite to be executed, maybe part of the test cases which will cover new added functionality. And third method is to prioritize test cases depending on business impact, critical and frequently used functionalities. This way we will greatly reduce the regression test suite for some release. Also, one important thing is QA pyramid. The QA pyramid is metaphor that give us idea how many tests we should have in each of these groups. If we want to get serious about automated tests for software, QA pyramid is one key concept. The pyramid says that tests on the lower levels are cheaper to write and maintain and quicker to run. Also, tests on the upper levels are more expensive to write and maintain and slower to run. Therefore, we should have lots of unit tests, some integration tests, and very few UI tests. Many companies test suites looking like an ice cream cone. This picture, right? Here they have a very few unit tests, some integration tests, and lots of UI tests, and also lots of manual tests. This is very expensive and hard to maintain. The unit test is an important part of writing high quality code. When people in software organizations speak of test automation, they tend to think of tools such as Selenium, which provides test automation frameworks. However, the team should first write tests at the unit test level. Unit tests are extremely fast to execute, and you will want to run them after every build. This approach will give you immediate feedback when regression occurs, as your code base continues to grow and evolve. Because of tests are so small and specific, it's easy to troubleshoot them and where you have failure. Then the middle layer of the pyramid is automated integration tests, but is also known as the layer of the automated API test, automated component test, or acceptance test. Now, when the majority of our code and business logic has been tested, most testing at the UI level has been eliminated. So our focus now at the UI level is simply to ensure that the UI itself is working correctly. UI tests are very brittle, so keep these tests at minimum. These automation tests will need maintenance anytime the UI changes. Also, one important thing is regression test plan. Because the next step is picking test cases to execute in regression testing, which depends on the business impact, frequency of use, and criticality of functionality. Taking these steps into consideration can reduce the testing effort and yield better results. In this phase, we should create test plan. Test plan will contain test scope, test strategy, and test estimation. This test plan will help people outside of the teams, such as developers, business managers, to understand the details of the testing. Test plan is designed to define the scope, approach, resources, and schedule of all testing activity for the release sign-off. While creating test plan, we have 5 questions that need to be answered. First question is what is the goal of the testing, and we need to understand how much coverage we need for the given project. We need to define this as clearly as possible. When the team encounters confusion around the goal of the regression testing plan, that's the point when these tests become expensive and ineffective. Second question is what kind of coverage does the software team want to form regression testing itself? Coverage is hard to track in regression tests. Often, one test covers multiple risks or areas of application. So we should take this into consideration. Next important also question is what techniques we will use to execute and maintain the test. This means how will we apply test automation with regression testing. Which test needs to be executed manually and who will perform them. Also, what skills QA testers should know and which areas of the application. What testing tools we will need to automate tests. We need to respond on all these questions. Next question is what environment we need to execute the test. We should consider what data we need to feed the application for these tests, as well as any custom configuration to be deployed. Keep in mind that some tests might need to be executed against different configuration of the program, and this is that we need to plan to manage that. And last question is how we will report the status of testing. We need to define how tester will report results, including the level of details, priorities, and obstacles for the test. At the end of our practice on our project, it showed that it's good to include everybody in creating test plan. With everybody, I mean business analyst, QA, and then team. If the QA team is missing maybe some technical knowledge, we can include developer who work on the implementation of some functionality to explain impact of this implementation of the system. So QA team can plan which test will be executed. Also, it's good if we have a QA member with better technical knowledge. He can investigate the impact of added functionality by himself. Adnan will take over from there. I will stop my sharing screen.
So I'm going to talk about, from the technical part, how we came to today's technology. Like we all heard about DevOps transformation. At the moment, it's literally everywhere. But what is it actually? Are we actually changing everything now? And probably these are the questions that we are all asking ourselves lately. Like DevOps transformation is a process by which a company transitions from a traditional or non-DevOps method of software delivery to a DevOps method of software delivery and maintenance. It sounds pretty cool. There is a traditional, non-traditional way of software delivery, or non-DevOps and DevOps methods of software delivery. But for the DevOps part, there is this maintenance, constant feedback. Basically, how I understood this phrase is non-traditional way is where we had Dev and QA teams. Dev team finished their job, it gets to QA. Basically, QA is testing it. It takes some time. QA then give green light. It pushed to new environments. It gets testing, so on and so on. We were so slow. In the past, it took us days, literally, to say that already coded item is actually ready for the user. This non-traditional way probably required less technical knowledge from the QA perspective and a lot of business knowledge. So today, those testers can be considered as UAT testers. But what about this actually traditional way that we are, or DevOps transformation that we are all hearing about? What happened with all others, like agile development, continuous integration, delivery, deployment? Basically, now all of that is DevOps, with one of the most important part, basically continuous feedback. Push the code into production basically and do the full monitoring. Where is QA in all of that? And like I heard many times the questions how it came so fast. Actually it didn't. Like UI automation started a long time ago, and most of us started doing it even 2013. It's basically evaluated to time to time, and we have to adapt any change that came in IT industry. Like first step was like agile development, and after that automation came. I mean, in the beginning it was really slow, but it got better and better. Most of you probably remember the first tool that you were using if you were working with Microsoft technology was Microsoft Test Manager. And we started like with developing test cases, test plans. We started to use even Lab Center. Later on, we were adding test controller, test agents. Basically, guys, I'm talking here about 2013. It's actually coded UI time, like Asian's history. Microsoft developed basically code UI to be the automation framework. I personally used it a lot for approximately 2 years. And during that period, I actually learned a lot. I learned to think what to automate, how to automate. I learned to play with a test rig, basically to create test controller, test agents, like build controller, everything I need in order to execute a test case. I started to think how to make my job basically more interesting and challenging. Then repeatedly doing same step to finish some small regression, whatever testing we are doing. When automation growth, we started to be basically with the automation growth, we have to actually accomplish some changes. We had to start trusting in code, testing the code. First of all, we had to prove it to ourselves. Then we also had to prove it to our clients. Yes, it literally took some time, but it was more than worth it. Then there was like, everybody heard about CI/CD. It was everywhere, CI/CD, CI/CD, that. Everybody read about it. It was even cool to say I'm doing CI/CD on my project, it's CI/CD. Industry really started to grow, and like efficiency and quality became, like quality is the number one always, but efficiency is also one of the most important things. So like after that, like we heard, as I said, like continuous integration, delivery, and now continuous deployment. And now there is like DevOps transformation. Actually, per my understanding, DevOps is all of that. It's just another step that we need to make. Basically, you need to implement all the previous steps that you see in the picture in order to fully transform to DevOps. But are we ready? Why everyone thinks it's something new? Like DevOps transformation is not like literally it's not something new. Yes, it has some additional add-ins, but it's more than normal because the IT industry is growing fast and it's adapting to new ways of doing software delivery. So DevOps transformation is just another step. So now the questions that we are having is where is QA in all of that? So basically we are going to develop the item, push it to production, till the production. We are going to maintain it there. Like where is, like who is responsible for signing off the item, like for quality, efficiency, delivery? Basically it's everyone. Like it's the team that's actually delivering the item and pushing to the production. Now I will go back to the all steps that we did in the past and how we started to adapt the new steps from the previous picture, and basically it started like 8 years ago. So first, like my first tool that I used was Microsoft Test Manager, and it was like 2012. Honestly, it was amazing. I came to work. There was the tool that has all written test cases in one place. And from the first day at work, I could be useful. I could execute a test case by just following the steps, and I could immediately contribute to the team. With that, like I could also learn the business knowledge, business logic of the application. Soon after, I got some features. I started create test cases. And my test cases were something like this. At the time, I was doing the best I can. Even today, we can see that people are just writing actions and expected results, which is fine. It's going to show us how to do and sign off some item. But actually, we have to rethink it. We also were creating folders, test plan, test suites, and basically it looked something like this. And even back then, we didn't understood the huge importance of test plan and test suites. And now with all of these changes, CI/CD, and now DevOps transformation, it's getting more and more out. I heard many times that manual work is not important. It's hard to explain how to take X amount of time to create proper test plan, proper test suite, test case. Basically, it's the most important part. It all starts from there. Like in the middle of 2013, I started with something new. Basically, I got the opportunity to work on automation. It was coded UI, and as I said, it was really great. I didn't have to do this manual work over and over with the same step. So basically, I was doing coding. It was a challenge back then because I remember in 2013, we didn't have so many videos and so many available documentation because Codia also started. Luckily for me personally, Authority Partners had enterprise licenses, so we had even a chance to talk to Microsoft team when needed. And like we were resolving issues and trying to make our automation work as best as possible. I also got introduced with the Lab Center that was actually controlling the test controller and test agents that were used back then for executing the test cases. So imagine in 2013, we already had a setup where you just needed a person that's going to automate things and just kick it on some agent machines, and you will get the feedback back. Selenium came later, and after some time, Microsoft stopped supporting Code UI. But which, like, are we using Selenium or something like it's less important? We have some challenges with the automation that can be resolved, and I will try to explain through this presentation. Basically, the challenges that we have and that I used to have is my automation used to be always ready for current build -1. Like whenever we were working as two teams, and whenever developers were actually checking in some item, and it was actually affecting my scripts. So I was always anxious when I'm running my test cases, is it going to be green? Or is it going to fail? Is it going to fail because there is some change in application? What we decided, like, it was really frustrating at the time, and we came to the point where we need to revisit how we are doing things. First solution was to create the engineering teams. So basically, Dev and QA team from the beginning are working together on the item and delivering the item till the end. So they are working on application coding, unit testing, integrations, UI test cases, and literally delivering the item to the end user. We developed a new process, and like we have automation in place. Basically, we had also test rig, test controller, test agents, unit test cases. We are working as a team. Basically, we had everything. It was pretty cool. But still, there was a problem. It took us too much time to develop the test cases, to add new one. Our test cases were getting obsolete in short period of times. XPaths are not stable enough for the UI maps. Like, we decided to do full re-engineering of everything from the scratch to see what we are doing wrong and how actually to improve. First, when you say to someone we need to do everything from the scratch, it's really hard. First, we have to admit to ourselves the way that we are doing, even if it's working and producing the results, is probably not the best way. We have to investigate. We have to search for better. We have to be curious, I would say. It's amazing how many improvements you can do when you understand that what you are doing currently is not the best possible way. I know, like, change is hard. It requires time. It requires to admit to yourself there is something better. But like, in the end, it really shows amazing results that you can accomplish as a team if you are ready to admit this. Like, first, as I said, we struggled with our test cases. They have to be up to date all the time, because what is the point to have thousands and thousands of test cases if basically you cannot run any of them in 6 months? So our test cases were not using shared steps. That was the first problem we noticed. And our framework automation basically is not fully connected with our manual test cases. So there were steps, we were automating those steps, we were creating methods, but there was no direct connection between two of those. And we were constantly adding new test cases because we couldn't recognize, like, if we are working on the new item, can we reuse just some test case? It was really hard to search for that. So first we did is basically we implemented the share steps. So let's say we have a page with all of these fields. So what should be our share step basic? In some test cases, we are going to need first name, last name. In the others, we are going to need first, middle, and last name, and phone number one. Like, it can be many combinations. So basically, the first thought, should we create multiple share steps, or we should create one? Definitely, the solution was one. So basically, you have a share step that's covering whole section. In some cases, if the page is smaller, it can even cover whole page. So after we implemented that, our test cases started to look like this. Basically, test case is not anymore action and expected results. It's just group of shared steps. But how we are controlling what we are populating when we are running these test cases? As you all know, all test cases have input parameters. So by default, we set all the input parameters on skip. That means, like, if we have test case that has to populate, like on the previous example, first, middle, and last name, we are going to provide all those three parameters inside the test case. But if you have the other test case that's using the same share step, basically that only has to populate first and last name, you are just going to provide those two parameters. So now we came to a situation where if something changed in the one section and we update that share step that's actually for that section, automatically we have all the cases up to date. So we don't have to go backwards and search the rest of the test cases and add additional steps, actions, basically how they are called. Like, we could do it by just changing one part of the system. But now, how it helps with automation, like we had to also connect those two. When I said in the beginning, the manual part is the most important, like I would say it's preparation. We decided basically to have share steps in manual test case to be the same in automation. So for example, if you have like TS personal populate borrower information in manual test case, in the automation, it will be the same. So it's going to be a method that's going to contain all the fields of that section, and and it's going to be controlled by parameters as the manual test case is also controlled. So basically, this is the share steps, how it looks, the manual share steps, where you have populate borrower first name, like last name, middle name, suffix, and etc. And then like you have methods for that. That's called the same step populate borrower information. So finally, we have a connection between manual test and automation tool. So basically what it means. With this setup, the automation test case, it's enough actually, in order to automate test case, it's enough to write properly the manual test case and just to copy paste the share steps, names of the share steps in the code and provide the parameters. Like you don't, like automation framework has to be easy to maintain, easy to use, and has to be like easy for everyone. If you are developing the automation framework, you have to make sure that anyone can use it. It's not requiring like senior level of dev knowledge or anything else. It has to be easy, and you have to have greater plan in order how to even improve it in the future. The next thing that we struggled were the actually UI maps, XPaths. So what we did, we decided as a team, since XPaths are not stable enough, we decided to add the attribute that's called automation IDs in our HTML. So every field in our application now has literally automation ID, where every page has unique automation ID, every section has unique automation ID inside the page, and every element has unique automation ID inside the section. So now it was pretty simple to create the UI map. Then we created the Chrome plugin that's automatically, as I said, all the test cases are controlled by parameters. So we created the Chrome plugin that's automatically taking the parameters from the test case and generating this XML file, and your test case is ready. And now, since we are not done with Reengineering, and probably will never be, we'll always search for new, the plugin that we are also developing at the moment is to generate the UI maps. Why we are able to do that is because we agreed about the hierarchy, how the parents' IDs are going to look like in one page that's actually presented. So now we are developing actually on one click to do the updates of any UI map and to generate the new UI map. And also the next step for us is going to be to create the literally Chrome plugin that's going to generate the test case by just reading the share steps. So basically our final goal is to automate the automation. Why this is important? Again, it's all about efficiency. We have to be efficient when we are delivering the items. When we fix the framework and add all these add-ins to speed up everything, what's left is like we used to have a lot of new test cases. Any feature, any change, we were creating a new test case. And like, since we have all of this setup, it was really easy to solve this problem. Basically, if you have a change in, this is just an example like step upload borrow information, you can make the change and easily see in the links how many test cases are using it and just reuse one of these test cases without adding additional one. because it's pointless to do same steps over and over again for just to check one additional validation point, since you can use already developed test case. We have to all understand that, as Nedim described in the QA pyramid, we have to understand that actually UI test cases are the slowest. So we have to be smart when we are actually adding additional one, and we have to be smart when we are actually deciding what our test plan is going to be for each release. So after we did all of this, we changed the process, how we write manual test cases, automation, framework. We were ready to accommodate CI/CD basically, to have our framework up and running with all changes in the application. At the moment, automation code is actually part of the application solution, so let's say dev solution. And so we are creating like the feature branch that has inside the automation framework as well. We are doing application changes, we are doing automation changes, we are merging all of that in trunk. And that item that's bringing changes in the application, it's also bringing changes in automation. So your automation is always up to date, basically, which is crucial in this moment, because if you want to achieve CI/CD, you have to trust in your automation and have it actually up to date. I heard many times that we need this and this version of TFS in order to implement CI/CD, like everybody's saying we need like now Azure DevOps. Basically, it's not true. Even TFS 2015 and 17 can fully support CI/CD like without any problems. Yes, in 2015 there are some challenges how to do that, but like it's doable, because 2015 was mostly created to work with Microsoft Test Manager and Lab Center, and with vNext it's not possible to do parallelism to run the test cases on multiple machines from the same assembly. Like in order to go towards CI/CD and even DevOps transformation, actually the QA pyramids is the most important part. You need to have right amount of coverage for unit testing. I would say even 80+%, like right amount integration test cases, and smartly choose an end-to-end test cases. Because if you have end-to-end test cases, the execution is lasting for 3 hours, I'm not sure that you are fast enough, basically. So basically, you have to be smart when you are developing the test plan, and actually when you are developing also the manual test cases. So that's why like preparation, manual work of QA, preparing the manual test case, test plan, test suite, and everything should take a lot, because if you do that properly, the delivery is going to be faster. I will try to explain now how to actually create a pipeline, release pipeline with TFS 2015. As most of us actually know, like it was working with Lab Center, Microsoft Test Manager, and it was using Dzemal build definitions, but also it supported vNext build definition. So the problem with vNext, as I already mentioned, it's not possible to run test cases on multiple machines from the same assembly. Of course, there is a solution for that. You can create multiple assemblies, but personally, I didn't like that approach. So what we did, we basically just played with PowerShell. We literally set up the pipeline with PowerShell scripts, and to the PowerShell script we just send the test suite ID, and it's executing after the deployment. If test pass, it's moving to upper environment. If it fails, it's stopping, and we are reviewing what's happening. So how it works is basically you will add this task to the release like application release pipeline. You are just going to provide the environment name, build number, and what is the suite ID. Like in the configuration variables for each environment, you are going to set the, like for your smoke, sanity, warm-up test cases, what do you need, what suite ID to execute. And when I'm saying suite ID, basically I'm talking about suite ID that's generating automatically after creating any suite in test plan. Also, we implemented just to receive the feedback from the system automatically. Just email the report. We will see the situation, and the same thing, and actually much easier, you can do in TFS 2007. TFS 2017 basically will use just the vNext build, and Microsoft did everything for you. Parallelism works. You will just need to choose test plan that you want to run. You need to add it in the pipeline. Test agents are deploying automatically, and basically it looks like this. You are going to call the task that's called Visual Studio Test Agent Deployment. You are going to provide the machines that are going to be used as test agents. And next thing, you are going to call Run Functional Tests task, where you are going to choose test plan that you want to execute. So literally, you are going to just click on the test plan, and that is actually the test plan that Nedim was also discussing before, where you can actually choose what do you want to be executed during this build. On the previous slide, you were choosing on how many agents and which agents you want to execute it. So by just selecting smoke, warm-up, regression, Mizmo, whatever you need in this case, that's automatically going to be pulled from TFS and actually executed on the agent machines. So the team will actually how to sign off release through TFS pipeline and still assure the quality. So basically, you need to do all the steps that were discussed. So basically, you need to do re-engineering of everything you did now. You need to have all of your test cases up to date. Like maintenance tasks, like my personal opinion, like test case maintenance shouldn't exist, basically. Like test case maintenance is done through the development of the new features and new items that you are working on. Like manual preparations is extremely important. Develop the pipeline even today and add continuous error until you feel comfortable to have automation as a decision maker. And really, engineering is really important, and feel confident to do it. I'm going to post on our Authority Partners blog full description about PowerShell script and how to set up each pipeline from TFS 2015, 2017, and Azure DevOps. So guys, you can always go there and find new interesting topics that Authority Partners is posting. That would be all from me. We are actually now open for any questions, Nedim and myself, if there is any, of course.
Not a question, more of a comment that actually verifies what you're saying, Adnan and Nedim. I was reading an article that was mentioning how the software delivery changed through the years, and how agile development was focusing on getting more faster, like the feedback and the releases. But even if we think that DevOps is again on taking the feedback more frequently with continuous delivery and continuous integration, actually DevOps is focusing on the quality piece of what we are saying and of the application. So I think your presentation, guys, covered this part. Thank you.
Okay, guys, then thanks a lot for giving us actually the opportunity to share a bit of history that we did in past few years, and additional more detailed topics you will be able to find in our Authority Partners blog that we will update end of the next week. So now we have my colleague that's going to take over.
Hello everyone, my name is Dzemal and I work at Authority Partners as a software engineer. I like DevOps, I like working with new technologies, and today's topic will be Azure Kubernetes Service. Before we start talking about Kubernetes Service, I assume that some people are not that familiar with concept of containers. So we'll start talking about that first. Then we'll move to Kubernetes. We'll explain its architecture. And after that, we're going to talk about Azure Kubernetes Service, its features like scaling and Azure Dev Spaces. And finally, we'll have a demo to show how that actually works. Before I start, I'd like to, in case you have any questions, you can write them in chat. And after the presentation is completed, I can answer some of those. Okay, so the old days. Early on, organizations run application on physical servers. There is no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. So, for example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resource, and as a result, the other applications would underperform. Solution for this would be to run each application on a different physical server, but to be honest, that did not scale well. Resources were underutilized, and it was pretty expensive. Then we got VMware. So as a solution, virtualization was introduced. It allows us to run multiple VMs on a single physical server's CPU. Virtualization allows applications to be isolated between VMs and provides another level of security, as the information of one application cannot be freely accessed by another application. It allows better utilization of resources in a physical server, allows better scalability because applications can be added or updated easily. It reduces hardware costs and much more. Important to say is that each VM is a full machine running all the components, including its own operating system on top of the virtualized hardware. And today we have containers. So container is a standard unit of software that packages up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. Containers are similar to VMs, but they have relaxed isolation properties to share the operating system among the application. So containers are considered lightweight, and similar to VM, container has its own file system, its own CPU, memory, process space, and more. Let's explain that with images. So here we can see hypervisor architecture. On the bottom, we have a physical server, and in here we have multiple VMs. Each VM has its own software, its own operating system, and on top of that, we install our application. We use VMs all the time today, and it works fine. It's great, but you can see here that we have multiple operating system to maintain, and in case you have to buy a license, it can be pretty expensive. With container architecture, we have physical server on the bottom, but we have a single operating system. And on top of that, we just spin up our containers. And in case we want to add multiple instances of our application, well, we can do that in a matter of seconds. So most containers spins up in less than a second. Okay, let's now talk about Kubernetes. What is Kubernetes? So it's basically a tool for managing your containers. In case you have few containers, you can probably manage them easily on your own. But in case you have hundreds or thousands of containers, it can be really challenging to manage all of those. So in those cases, we use Kubernetes. It's a portable open source platform for managing containerized workloads and services. We can see some basic information about Kubernetes. You can see that it originated in Google. It's written in Golang. It's open source. You can find its source code on GitHub. And especially what I like, I want to say is the last sentence here. It's kind of similar to courier service. It's a declarative. Basically, you create a manifest file describing what you want to achieve. And you give that to Kubernetes, and Kubernetes will do the rest. It's the same like, for example, you want to send a package to someone. You just, if you have a package, you just write to whom you want to send it, and that's it. Post office might use planes, trains, whatever. We usually don't care as long as it gets delivered, and it's similar with Kubernetes. Kubernetes provides us with many functionalities. I just want to mention a few of those. So service discovery and load balancing. Kubernetes can expose a container using the DNS name or using IP address. If traffic to a container is high, it is able to load balance and distribute the network traffic so that our application is stable. Also, Kubernetes allows us to automatically mount any storage system of our choice, such as local storage, any cloud storage, and more. Automated rollouts and rollbacks. We can describe the desired states of our deployed containers using Kubernetes, and it can change the actual state to the desired state at the controlled rate. So, for example, we can automate Kubernetes to create new containers for our deployment, remove existing containers, and adapt all the resources to the new containers. Kubernetes also allows us to specify how much resources, CPU and memory, each container needs. If we specify that, then Kubernetes can make better decisions to manage the resources for containers. Self-healing, it's also another important feature. So Kubernetes restarts any container that fail. It can replace containers, kill containers that don't respond to user-defined health check, and doesn't advertise any unhealthy containers to the client until they are ready to serve. And the last, Kubernetes lets us store any sensitive information we have, such as password, tokens, SSH keys, and more in a secure manner. So we can update those without actually rebuilding our container images. Okay, let's briefly talk about its Kubernetes architecture. So in here, first you can see the master. It's one of the nodes in our cluster that kind of actually manages the state of our cluster. It usually contains 4 different processes. On the bottom here, you can see the API server. It's the only process that is public. And when we communicate with our cluster, we always use the API server. On the left side here, we can see scheduler, which is responsible for scheduling our containers. On the right side, there's the controller, which kind of manages Kubernetes objects for us. And here at the top, we have a cluster store that contains state of our cluster. It's basically a key pair database. Except for a master node, we always have one or more worker nodes. And those are nodes that actually run our application. They usually contain three different processes. The first here is kubelet. That is basically a Kubernetes agent. We also need to have, we need to install any container engine. It's usually Docker engine. And on the right side here, we have a kube proxy, which kind of manages a network for us. So how this works? Let's say we have some manifest in which we described our desired state. So for example, we may want to deploy 4 instances of our application. So when we have manifests ready, we give that to Kubernetes master. And then what happens is that Kubernetes actually schedules containers to be run on our nodes. I will briefly talk about Kubernetes objects. There are many objects in Kubernetes. A pod is the basic execution unit of a Kubernetes application. That's the smallest and the simplest unit in Kubernetes. It basically represents a process, our application actually running on our cluster. Deployment controller, well, as the name says, we use it to deploy our code, and the service is actually a very important object. It basically enables us to expose our application to the end user when deployed. There are many other Kubernetes objects, but we won't talk about this today. Okay, so let's talk a bit more about pod. So a pod, I said it's a basic execution unit of Kubernetes. It's actually a group of one or more containers, such as Docker containers, with shared network storage and specification for how to run those containers. It represents a unit of deployment, a single instance of our application in Kubernetes. Two facts are important to know about pods. First, they're atomic. So we cannot start half of pod. It's basically all or nothing. For example, if we have 2 containers in our pod, if one of those fails to start, well, then the pod won't start as well. And also, pods are ephemeral, meaning they are short-living. They get created and deleted all the time. When a pod gets deleted, it's never brought back to life, never. We can start another one that might look exactly the same, but it's not that one. So we need to be careful not to save any persistent data inside our pods. Okay. Deployment, as previously said, so deployment controller enables us to deploy our application to a Kubernetes cluster. So all we have to do is to describe the desired state in a manifest file, and then Kubernetes takes care about rest. It allows us to define our own deployment strategy. And how that works, we'll see a bit later in demo. Services. Kubernetes pods are mortal. They get created and deleted all the time, as previously said. And during that process, the IP might change. So we kind of need a way to be able to access all those pods without managing IPs for ourselves. And in those cases, we use services. Service is an object that can also do load balancing for us. It has features like we can like session affinity, and we can also enable round robin in case we want. There are 4 types of services in Kubernetes, and today we will use the third one, the load balancer type. Okay, so let's imagine we have some pods deployed, and let's call them backends. And let's also imagine that we have 4 front-end pods. So the question now is, how are they going to communicate? So one possible solution would be that every front-end pod have IP address of every backend pod. Theoretically, that might work, but it's not a good practice because, for example, if we deploy new version of these backend pods, the IP address will probably change. And in that case, front-end pods are unable to communicate with newly created pods. So that's why we use services. Instead of every front-end pod having configuration of IP address actually of every backend pod, we kind of put service between them. And now every front-end pod actually communicates with the service. And service then moves the traffic to the backend pods. Service can have a static IP address. It can be even a public IP. It can have DNS, so it's so we can find it in our cluster. Okay, so now our main topic is Azure Kubernetes Service, or AKS, which makes it simply to deploy a managed Kubernetes cluster in Azure. It reduces the complexity and any operational overhead of managing Kubernetes by offloading much of those responsibilities to the Azure. As a hosted Kubernetes service, Azure handles critical tasks like, for example, health monitoring and maintenance for us. Also, the Kubernetes masters are completely managed by Azure. In case we created our own cluster, we would have to maintain the master nodes ourselves, and we would probably need to have more than one in case of anything happens, and that makes us even harder to maintain. Kubernetes service is actually free. We only pay for the worker nodes we use within our cluster and not for the masters. And it can also be easily integrated with Azure Container Registry to store our container images. And also I want to mention that currently Windows containers, they're still in a preview support in Azure Kubernetes Service. So that's something to have in mind in case you plan to use this in your production environment. Okay, one of the most important features of Kubernetes and Azure Kubernetes Service is scaling. From time to time, we will have different needs for our application. So user amount might grow, and in those cases, we probably need more resources in our cluster. And there are multiple ways how can we scale our cluster. So the first one is manually. We can use, for example, Azure Portal or a Kubernetes dashboard to do that, and that works fine. But it's not ideal because in case we have a spike of users that happen during the night, we probably won't be able to respond in a timely manner. That's why there's a Kubernetes object that's called horizontal pod autoscaler. That actually monitors usage of our applications in the cluster, and it is able to scale our application in case the more resources is needed. So if we have, for example, a spike of users, it will probably in less than a minute create additional pods. And so our application will maintain its responsiveness. The next way we can scale our cluster is cluster autoscaler. So horizontal pod autoscaler will create new pods in case of need. It can also remove the unnecessary pods, but at certain point we may reach situation where there's just not enough resource in our cluster. So we need to provision new worker nodes. And that's the situation when we use cluster autoscaler. It will create additional virtual machines in our cluster in case of need. Their cluster autoscaler is typically used alongside the horizontal pod autoscaler. And the last way is currently in a preview phase, and it's called virtual node. Let's assume that when a spike of users occurs and we have higher resource demands, horizontal pod autoscaler will create additional pods. When there's not enough resource in the cluster, cluster autoscaler will schedule creation of additional nodes for our cluster. But if you ever created a virtual machine in Azure, you know that it can take, it usually takes 3 to 5 minutes. So there's a possibility that during that time, until new worker nodes are provisioned, our application might get unresponsive. And that's the situation when we use virtual node. It basically schedules our containers, our pods, using Azure Container Instance. This is very useful for applications that need to rapidly scale. And when we use it, actually Azure Container Instance become like a logical extension to our Kubernetes cluster. But considering that it's not the real node, it's called the virtual node. Okay, I won't talk too much about Kubernetes dashboard. I just want to say it exists. It's basically a web-based Kubernetes interface. We can use it to monitor health of our pods and the entire cluster. We can also use it to check logs, application logs, and to deploy a new application. In a demo later, we'll open the dashboard and see what can we do with that. Okay, and the last feature of Azure Kubernetes Service I want to talk about today is Azure Dev Spaces. Developing a Kubernetes application can be challenging. We need Docker and Kubernetes configuration files. We also need to figure out how to test our application locally and interact with other dependent services. We also might need to handle developing and testing multiple services at once with a team of developers. So in that cases, Azure Dev Spaces is a great tool. So it enables us to connect our development computer to our Kubernetes cluster. And that allows us to run and debug code on our own development computer as if it were running on the cluster. So Azure Dev Spaces redirects traffic between cluster by running a pod on the cluster that kind of acts like remote agent to redirect traffic between our development machine and the cluster. It's also it's easily integrated with Visual Studio and Visual Studio Code. It's of course used mainly for testing and development, but it's actually a great tool in those cases. Okay, so that was enough talk. So we can now jump to a demo. First, we will create Azure Kubernetes service. Then we're going to connect it from our own machine. After that, we'll create CI/CD pipeline. Then we're going to deploy the dashboard and our code to the cluster. After that, we'll deploy the service. So our application is then publicly accessible, and we'll finish the demo with some autoscaling. Yeah. Okay. So here we are at Azure Portal. Well, as with any other resource in Azure, we click Create Resource, and there's a Kubernetes service right here. The creation is fairly simple. First, we create a resource group or use existing if we have one. We give a name for our cluster. Let's say, okay, that one's free. We can choose multiple versions of Kubernetes to use. I'll just leave with the default one right now. And on the bottom here, we select the VM size. You can choose whatever you like. It doesn't matter really. And finally, we select a number of worker nodes for our cluster. Let's jump to next tab. I usually enable both of these features. So virtual node is a feature we talked about in presentation, and the VM scale sets is a feature that actually enables us to scale our Kubernetes cluster. All of the other options, if you're creating Kubernetes cluster for the first time, then I suggest you just leave it as it is, because it's just fine. I just suggest that you enable container monitoring, because that can come very useful. Okay, so now we can create our cluster. I won't click create because it can take up to 10 minutes to create, and I have one created before this demo, but now at least you are aware how to create one. Okay, so here's the resource group in Azure that I use to deploy our Kubernetes cluster, and you can see it's right here. So there are many options we have here. I'll get back to this later, but don't be surprised if you see another resource group created. That happens automatically. In my case, this is the one. But this all gets created by default. You can see load balancer and IP address. All of that is created by default, and we will use this IP address later to access our application from the outside. So this is public IP address. Okay, so we have our cluster deployed, and now let's access it from our own machine. For that, I will use PowerShell. and you need to have Azure CLI installed as well as kubectl. kubectl is a tool that we use to interact with Kubernetes cluster. So first, we need to log in. So this actually brings up a new window. Okay, so now we logged in successfully. And now we use a following command to connect to our cluster. You need a name of your resource group. In my case, it's just called Kubernetes. And then we need a name of our cluster. In my case, it's EP demo. So hopefully this will connect us to the cluster. This way of interacting with the cluster is useful because unless you probably don't need this if you're using Azure Kubernetes Service because you have Azure Portal, but in case you don't, you can always use PowerShell. If for some reason it takes a bit long.
Did you maybe pause the screen by clicking in it? I see that.
Yeah, I'm not sure. I don't think so.
Maybe try pressing escape or something.
Let's try entering. It doesn't respond. Well, these things usually happen when I have a demo.
Excuse me, Dzemal, you have a typo, yeah?
Sorry?
Kubernetes.
Oh, yeah,
test.
you're right. Yep. But still, yeah, it's frozen. So let me open a new window. Thanks.
Control C to
Yeah,
stop
I
execution.
tried that, but
Okay.
it looks like my machine is frozen now. I can't click on anything. Okay, that's just great.
Don't worry, we have time.
Yeah, it's not like we have some place to be.
Yeah, exactly.
That's good.
You make a typo and it completely froze the machine. Well, we could use this time in case someone has questions.
I have one.
Yep.
Ever considered teaching on Udemy?
No.
Shame. I would pay for this.
Okay, thanks for that. I got a message on my other screen that says that Microsoft Windows does not respond.
I have a basic question. You mentioned that it takes around 10 minutes for Kubernetes cluster to be created in Dzemal. Why it takes? What's going on behind?
Well, I'm not sure about details, but first it needs to provision VMs. So that alone takes 3 to 5 minutes.
Okay.
And it also needs to configure a load balancer, IP addresses, and a network behind all of that. So as before, we need to log in first. that's done. Let's bring the PowerShell back. This time I have command written in Notepad, so I'll just paste it here. But it's the same command. We just need name of our resource group and name of our cluster. Okay, so it works now. To interact with our cluster, we use a tool called kubectl. It's fairly easy to use. We can use it not just to get the state of our cluster, but to deploy anything we want. So I'll just write command. So just to check if there's anything already deployed, and as you can see, there's nothing there. And that's fine. During our demo, we are going to deploy some code. Okay, so for this demo, I prepared some sample application. It couldn't be simpler, to be honest. It's just index.html with plenty of text. And I also have, in my repository, I have a Docker file. In here, you can see that our container will be actually Nginx server that will expose our application on port 80. We also have here some Kubernetes manifests that we are going to use to deploy our application, and I will explain these in detail a bit later. To deploy our application, first we need to have CI/CD pipeline. So we could go here and create our pipelines from scratch. We could use tools like Jenkins, TeamCity, that's fine. But there's even easier options, especially if you don't want to waste time on creating pipelines. Now let's go back to the Azure portal. We're going to open our Kubernetes service. And on the left here, there's an option called Deployment Center. You can see it's still in preview, but it's fine for testing purposes. And this will actually generate a complete CI/CD pipeline for us. All we have to do is to follow these four, to be honest, fairly simple steps. So my code is in Azure repos, so I'll just click next. I select my DevOps organization. Select the project I want. So repository and the branch, that's all fine. You can see that it scanned our repository and it found the same Docker file I showed you a minute ago. We can modify something if we want right here. This is fine for me, so I'll just click next. And the last thing we need is a container registry to publish our container images. So we could create a new one right here, or we could use existing. I have already one created, and you can see it's selected right here. And that's basically it. If we click now here, done, this will generate a CI/CD pipeline for us. This takes 3, 4, 5 minutes, depending. So I have this already created, so we won't waste time. And let's go back to Azure DevOps. And let's find our builds. In here, I have our build pipeline. Let's see what's in there. The most important part is actually the first step that builds and pushes our container image to the Docker to container registry I created. All I have to do is fill some of these options, and it's fairly simple. You can also see that when I used the option to generate CI/CD pipeline, it also created all required service connection here. so I didn't have to do that manually as well. And as last step, I just publish these Kubernetes manifests file because I want to use them later in our deployment phase. So let's queue one of these deployments. Considering that it's a fairly small application, this shouldn't take much, hopefully. Okay, that's done. So now that we have our build and container image created, we can deploy our code. You can see that I created multiple pipelines here. When you generate a CI/CD pipeline, it usually just create one to deploy our code, and that's this one. And we're going to show that a bit later. But before that, I want to talk about Kubernetes dashboard. I already mentioned that in my presentation, but important thing to know is that Kubernetes dashboard is not deployed by default. So you have to do it on your own. Let's see what we have inside this pipeline. You can see there are 3 steps. The first one will actually deploy the dashboard. The dashboard is just basically like an extension to this. It has its own YAML file. It's available on this URL. We can even see that right here in the browser. You can use the default one. You can edit if you want. I will just use the default one. And there are 2 other steps that basically deploy our admin user. I won't go into details how this works. At the end of my presentation, there are some useful links, and in there you can find a detailed explanation about this. I will share my presentation at the end, so you can find those links. Let's now deploy our dashboard. Okay, that's all done successfully. And now we have to access our dashboard. By default, dashboard is not accessible outside of the cluster. So there's still a way how you can access it. And again, we are going to use PowerShell with kubectl. We just type a simple command, kubectl proxy. So now this will act as a proxy between us and the cluster, so we'll be able to access our dashboard. Dashboard is always available on the same URL. And now we need to authenticate. In case you're running production clusters, I suggest you use first option, but I just generated admin token, which enables me to access with full rights on this cluster. And again, instructions for this will be shared at the end of the presentation. So let's access our dashboards right now. You can see that okay, so first, let's check the nodes in our cluster. Currently, there's only one, and you can see it here. There's virtual node here. We talked about this during presentation. It's not a real node, and we don't have to pay attention to this one. If we click on the left side here, there are deployments. We can see that there's nothing deployed, and that's fine because we haven't deployed anything, and that's actually the next thing we're going to do. So let's go back to Azure DevOps, and we have a pipeline that's called deploy code. Let's see what's in there. In here, you can see that all we have to do is basically give a manifest file that we have created, and it's called deployment.yaml. I promise that I will explain meaning of those manifest files, and let's do that right now. Okay, so here's our deployment manifest. It looks fairly simple, to be honest, but let's go step by step and explain what all of this means. So in here, first we say this is a deployment. We have some metadata right here, and then we have a very important part. So first line here says that we want to have 4 instances of our application. The rest here is actually our deployment strategy. So you can see that we are using a rolling update, and all of this means that our containers will be updated one by one. And between those updates, we will wait for 2 seconds. In a real in production environment, you might want to put a bigger number here just to make sure that what you just deployed actually works. Just to make sure it won't crash. We can also change these numbers here, so we can deploy our applications in batches. That's fine. I have a small application right here, and I decided to do it one by one. On the bottom here is actually what are we deploying. You can see that in here we specified which container image we want to deploy. And this is actually from the build we ran a few minutes ago. This here means that port 80 of the container will be mapped to port 80 of our Kubernetes pod. And last part is very important for scaling. This basically means that our container, our pod actually requires 1% of single CPU core, and the maximum amount of a CPU our container can have is 10%. When we talk about scaling later, all of this will have some meaning. So let's go back to our pipeline and deploy this manifest file. It shouldn't take much, to be honest. And now it's done. So let's go back to dashboard. We click deployments, and right now you can see that there's something deployed here. It's still all pods are still not provisioned, but they should be very soon. And actually, it's done. So before we didn't have any application running in our cluster, and now, as you can see, we have 4 instances, and all of those are up and running. When you click on the deployment here, you can find many details. There's option on the right side here. You can delete resource. You can actually edit the manifest file. which I just showed you, and you can scale our application. And let's actually do that. So this is an example of manually scaling our application. So let's put 40 right here. And let's click scale. So we should see numbers changing here, and you can see that there's already 12 instances of our application available. And if we click again on deployment here, you can see there's exclamation mark, which basically says there is not enough computing resource in our cluster. So we have 13 pods and we still need 27 more. So now a cluster autoscaler will try to provision more nodes. So currently, as I said, we have only one, but in a few minutes, you will see that there's at least one more. This provisioning of VM may take a few minutes, so we don't have to wait here. Now we can think of way to access our application now that we have it deployed. As we said in the presentation, for that we are going to use Kubernetes object that's called service. We have a separate pipeline for that one. It's same as the one before. We are just using different manifest file that is called service.yaml. So let's open it up and see what's there. It's even simpler than the previous one. Again, as we said that this is service. It's type of load balancer, and we assign it a public IP address. So if you take a look at this IP address, you can see that's the same one that's been created right here. So it's the same IP address. So basically we want our application to be available at this IP address. So let's deploy our service now. So while this is deploying, we can check the state of our cluster. So you can see that virtual machines are still not provisioned. So this would be probably this would be a good situation to use virtual nodes, a feature we talked about in presentation that would enable us to create all the necessary pods within a minute. But I haven't configured that because I wanted to show what's the potential issues we can face even if we have all those auto-scaling enabled. Service should be deployed soon. And it's done. So now go back to our dashboard. There's on the left, we can see services here. If we click there, we can see the service I just deployed. You can see it was created 35 seconds ago. And you can see its external endpoint. So if we click here, that should give us our application. Although there might be some performance issues because the entire cluster is having some problems with scheduling new pods. Okay, so there it is. So it's definitely not the most beautiful app you've seen, but that's not the point here. The point is that our application that is running inside Kubernetes cluster is now publicly available. There's also DNS name associated to it. We could test with that as well. It should give the same result. And yeah, I was correct. You can also test on your own if you want. That's fine. Okay, so back to the dashboard. Now we can see that there's all 40 pods created. If we check the number of nodes, we can see that the cluster autoscaler created 2 additional VMs, and now they are part of our cluster. So we didn't have to do anything. This could happen in the middle of the night, and this could actually automatically provision more computing resource to our cluster. And it's amazing thing, really. Now I will return the number. I will scale down the number of pods. This should happen very fast. Yep, you can see it's already down to 1. And the last thing I want to show today is horizontal pod autoscaler. I already talked about that during presentation. There's again pipeline for that. It's same as the other one. We're just using different manifest file. So let's open that manifest file and see what's there. We say this is horizontal pod autoscaler. What we have to say is that we want to target deployment that is called AP demo deployment, and that's actually the one we previously deployed. So basically that means that we want to scale pods that were created by this deployment here. We also defined minimum and maximum number of instances of our application, and we also define metrics by which we want to scale our application. So in this case, whenever average utilization, a CPU average utilization across all pods is over 50%, this will create additional pods. So we have to deploy this autoscaler as all the other Kubernetes objects. It should be quick, hopefully. And it's done. This is something you can't really see through the dashboard. But if we go back to Azure DevOps, I have a load test created here. So we can simulate load of users. And if we create enough load, hopefully that will automatically provision more pods. So let's start this test. It should run for 4 minutes. There should be 100 users per minute. So it will take a few minutes before this starts. So let's go through what we are expecting from this test. So if we go to the dashboard, we can see there's currently a single pod running here. What I expect to happen is that during this test, single pod won't be able to serve all those requests. So horizontal pod autoscaler we just deployed will provision multiple pods depending on the load. And later we can see the charts where actually response time should be higher at the beginning, and after a minute, or let's say half a minute, when new pods are provisioned, response time should be lower. Okay, so all we have to do now is wait for this load test to start. I hope it will start soon. While we're waiting, does anyone have questions? Okay, then I guess we'll just wait. And it started. So it's been already running for 40 seconds. I'm not sure whether this already affected our application. No, as you can see, it's still a single pod running. But in a minute, there should be more pods created.
While we wait, we have one question from Eldin in chat. So
Okay, let me open the chat. So the question is, how do we know how much CPU to assign to handle our workload, but also not to assign too much? Actually, that is a very good question, but there's no single answer to that. You have to know your own application. You have to know whether it's performing some workloads that requires high CPU. It's just that there's no good answer. You have to decide for a specific application. It's hard to do that, but after some time using Kubernetes cluster, you will actually find what are the correct values. I hope that answered your question. And let's now check our dashboard. And yeah, as you can see, we now have 3 pods available. So we had one, then we simulated load of users, and then horizontal pod autoscaler created 3 additional pods. And also a very important thing is this graph right here. As you can see, at the beginning, the response time was higher because we had single pod, and it just wasn't able to serve all the needs. After exactly 30 seconds, we had 2 other pods created, and in this point of time, you can see that response time got back to normal. And the reason why can we see here 30 seconds is because horizontal pod autoscaler checks for the metrics every 30 seconds. That's the default value. In case that's too high for you, you could just put it for 5 seconds to give even better response time for your application. We don't have to wait for this test to end because I just wanted to show that this actually works. It's not just inside the book, but it works. So we have it right here. There's another just last thing I want to mention is if we go here in Azure portal, we click on our Kubernetes service. There are many options here. So we can scale our application right here. We can create additional node pools. We can upgrade the version of Kubernetes we're using. Many other options here, but I also want to mention is container insights. That enables us, well, insights basically in a health of our cluster. It gives us many useful information. We can see that the number of nodes increased when we created 40 pods. There are many useful informations here, and there's also option to connect to a specific container and check its logs, basically just to check the live data. I don't think my container will show any logs, but in case you have some custom logging, and in case actually something happening inside the application, you would see that right here. To be honest, that's it from my side. I hope you enjoyed it. I would like to. Okay, I can see some other questions in the chat. Why do we see a peak in performance chart if the number of pods didn't change? I'm not sure at which point was this, but number of pods did change. So we have one pods, and currently we have 3 pods. Considering that our load test is done, in a minute or 2, this will go back to 1 pod, because there's just no need for 3 pods, and we want to save our resources. Any other questions?
Is this time configurable? How long will it wait for dropping down back to 1 pod?
Yeah. All of that is configurable.
Okay.
Any other questions? Well, if no, then I guess that's it. Thank you for listening to me. It was over an hour. Sorry for the issues I had with my machine, but important things that we managed to complete this presentation.
Thank you, Dzemal, and thank you all for presenting. It was really great experience, and I wish we keep this going. Thank you.